properties of these operations. First of all, number one, we call it a commutative law. The order is unimportant. Either x plus y or y plus x will get the same result. Secondly, quite often we need to add more than two terms or two vectors. So if I add x plus y and then z, alternatively I could have added up, the brackets show the order. Firstly, y and z, after that x, and I get the same result. Property number 3, it's about the zero vector. So zero vector exists, and it has the property that when I add any x and this zero vector, I always get x. So what this zero vector means in the Rn space? This is a vector which is represented by a column made of zeros. They're all zeros, all coordinates are zeros. Number 4. For any x, there exists an opposite vector, represented by minus x, whose property is when I add to this minus x opposite x, vector x, I get 0. So these are properties of operation of summation. Now, the rest will be properties about multiplication by a scalar, and also there are some properties where both operations are combined, like number 5. When I multiply a sum of two vectors, x and y, by the scalar lambda, instead I can multiply lambda by x and by lambda by x and y and add them up. The same true for multiplication of the sum of scalars. This time the first scalar is lambda, as earlier. Another scalar is, I'm using Greek letter mu. So I get the same result if I instead multiply x by lambda, x by mu, and add them up. Both properties number 5 and number 6 are called distributive properties, distributive laws. A particular case of a scalar is number 1. So if I multiply by 1, and I multiply by 1 any vector, I get the same vector x. And the final property, number 8. What if I need to multiply by a scalar twice? Firstly, I'm multiplying x by mu and later by lambda, at the same time I could have multiplied lambda and mu and then by x. Here we put a dot, so we exhaust all these properties. The next topic would be inner product. In Rn. I take x and y, two vectors, from Rn. Now, I'll be using triangular brackets to denote the result of multiplication. So the inner product of two vectors from Rn is a real number which can be found by the formula. This is a summation symbol. And here, right, xi being and yi being the coordinates of these two vectors. If I multiply x by itself, according to the formula, I have the sum of squares and we know the sum takes only non-negative values. That means I can find the square root of the sum. And this square root is called the norm of vector x. The norm is the same as the length. For example, if I'm working in R2 space, so let x be from R2, and let us choose some particular vector. This is a two-dimensional vector, the first coordinate being 3, the second being 4. What will be the norm of this vector? The norm of this vector will be the square root of the sum. So the length of the vector is 5. On the basis of a norm, we can calculate the distance between two vectors. So let's suppose we have two vectors, x and y. How to find the distance? We need to find the square root of the sum.